Hey, welcome to tonight's live stream. This is Jacob Jewett, and you've joined my twice weekly live stream. I have on Sundays, I usually start at 6 p.m. Pacific time and 9 p.m. Eastern Standard Time, and I do the same times on Wednesday. So Wednesday from 6 p.m. Pacific time and 9 p.m. Eastern Standard Time. Tonight I'm starting a little bit late. I started at 7 o'clock, or a little bit past 7 o'clock. I had some problems starting the stream. The reason for the stream starting late to start with is I got stuck in LA traffic. Decided to take the family on a little mini vacation, and we went down to the Midway down in San Diego, and thought we left early enough to get home, but traffic, construction, more traffic, a couple accidents, all that fun stuff kind of stopped us from getting back on time. And unfortunately, I can't let people know through my phone or through the live stream when I'm on the road, so it didn't quite work out. But anyway, that's about the fun of today. So if you haven't joined before, as I stated before, I do these live streams twice a week. I open up the live streams to any questions that you may have regarding the A+, Net+, any CompTIA certification, IT in general. If I can answer it, I will. If I can't answer it, I'll certainly find you an answer. Pretty soon, I hope to do some live streams where I actually have guests with me, people that not only myself, but other people that work in the industry that I am friends with, and we can share our experiences with you. Last week, or not last week, but last Wednesday, I actually had a gentleman join and ask quite a few questions, and he got just about all of his questions answered because he was the only one on the live stream. About 4 live streams ago, or 2 live streams ago, I mentioned that I'm going through the process of recertification. So I thought I'd take a moment to show you kind of what you get when you pass the certification exam from CompTIA and what they do for you on that. So I figured I'd share that. Again, I recently passed on September 21st. I completed the certification process, recertifying in A+. I've held 3 different A+ certifications. This would be the 3rd. The first A+ certification I held was actually a lifetime cert. I passed that certification back in 1999, and that was my first A+, and that was the first real certification I passed. And then in 2011, I recerted on it again. And of course now in 2018, I have recerted on it once again. So that would be, that certification that I passed was the 1020, sorry, the 1020, was it 201 and, or I'm bad. So the brain fart, 10-901 and the 10-902. So I have basically the packet they give you when you pass the certification exam. And good old congratulations on it. In the past, I've only gotten these packets when I've actually passed the first certification in the series. Usually, I haven't gotten the follow-up packets for some reason. But when you open it up, the first thing you'll see is your actual certification certificate. So you'll see here that I got the A+ again on September 21st. And it tells you a little bit about CompTIA A+ and our CompTIA certifications. And it has a nice little board in there to try to keep your certification all nice and neat as it comes through the mail. And then attached to the folder, they actually give you a card. So you don't need to go around with a certificate identifying that, hey, I'm A+, you can actually put this card in your wallet. And as you said, I just got this in the mail, literally as I got back from my little small family vacation. I just got this in the mail, and just has you, it just basically has, other than your card, has things to tell you about your ways to leverage your certification, stuff like that. All really stuff that's available on their website, but it's kind of nice that they actually send it to you as well. And then, as I said, they give you a nice little card here that identifies you as a certified personnel. And that's mine. So as we go through these video series, I plan on recertifying in them as well. So right now I'm trying to get through the Net Plus certification exam series, and I've kind of hit a bumpy road on that. Not that I have a hard time understanding the information, or you know, I've taught the class plenty of times to understand the information and be able to regurgitate a lot of it. What I try to do with the Net Plus certification, oh, there's a nice spider going across my floor. Last Wednesday, it started out as having, a fly that wouldn't leave me alone. Now I have a spider. Let me get rid of that sucker. I don't want that sucker in here. I don't know where you went, but there's a, I actually saw in the screen that I had a spider going across the screen in the background. It's kind of funny. So, I don't know where he went, but yeah, so if it's not a fly, it's a damn spider. Anyway, as I said, Net Plus, I've passed it before. It's not really a problem for me because I you know, taught it quite a few times and things like that. But you know, what I want to do is, as I'm going through the certification course and building it up and things like that, at the end of it, I myself am going to recertify in every certification course that I actually put on to this YouTube site. So I have the Network Plus that I'm doing, and I'm doing that right now. And then I also have the A Plus that I want to do as well. But if you look at my channel, I've been really trying to kind of go with the newer stuff. So I messed up on the certification numbers before, but the 220-901 and the 220-902, those are old certifications. And I got some loud kids. Let me ask my wife to actually ask them to be quiet. Anyway, they forget that I'm doing a live stream, and so they tend to be loud. But I passed the certification, the A Plus certification that I passed with the 220-901 and the 220-902. And they are getting ready in the first quarter of 2019 to release the new A Plus certification, and that is the 10-1000 series, or not the 10-1000. I think it's still the 220 series, but starting with the 1000. So it's 220, 1001, and 1020, or 220, 10,002. It can be kind of confusing, but that's what they're going with. So when they actually publish the objectives to that certification exam, I will print that out and probably find another book that I will be using as a guideline, which kind of leads me to this. So if you notice, I haven't been producing a bunch of videos. I've been doing a lot of recording for the videos, but it's kind of what ends up happening is I I seem to be doing a trying to reinvent the wheel kind of setup. So when I first decided that I was going to do the Network Plus certification exam series, I was going along the lines of I'm going to use a book, which I did choose a book, and I do have it. So this is the book I was choosing to operate out of. And let me go to demo so you guys could see this. And bottom screen, so that works. So this is the book that I'm trying to use as a guideline. Again, as a bit of, I'm gonna do a review on this, as a bit of like, you know, gee whiz, that's wrong, cancel. As a gee whiz, you know, let's use this book, and it's good because I don't have to reinvent the wheel. And again, when I say use a book, I don't mean copy word for word out of the book. I don't even really get my material from the book. More as I use the book as a guideline of making sure I cover all the objectives. And I kind of moved away from this a little bit recently, and I really, really need to stop. I need to actually use it like I had been planning to use it, and just kind of go from there. So what I did was I kind of branched off away from it, and I decided that, you know, okay, I'm gonna go through the actual exam objectives and kind of explain each one. So what I did was I started off with a book. I looked at it as a guideline, and I went, okay, they're operating right now out of 1.5, objective 1.5, and gee whiz, I'm going to cover that, and then I'll go back to the book, see what they cover next, blah, blah, blah. But if you were to get this book, which I do have a link for it, for Amazon link, and so you can buy it, or I have a link to Safari Books Online where you can subscribe with their service and actually get as many technical books as you want. One of them being this book. With their subscription, there is really no limitation on how many books you get or how many books you use. So it's well worth the dime to pay for that service. So what I'm going to do is you know, use that book, of course, as the guideline, and I'm going to go back to what I initially planned. So and the reason why is because, again, I kind of got a little scrambled, but if you go to the first chapter of that book, it does a really good job in the first chapter talking about not the OSI model, but it talks about servers, workstations, and hosts, LANs, WANs, and MANs. If you watch my video, the first video I produced, I actually, the first video on Net Plus I produced, I actually went into better detail, I think, of, you know, what the difference is between a LAN, WAN, and MAN, whereas they're very quick with it. It goes down to like maybe 3 or 4 paragraphs. But the problem is if you don't truly understand the difference between the sizes of networks, you can kind of get lost and not understand. And I've had a lot of students actually do that. They get a little bit lost because, you know, they'll get the first chapter, which is an introduction chapter to the book, and they'll get really lost because they'll only get that little bit of information. So what I plan to do is I'm going to use the book as my guideline, and I'm going to go chapter by chapter through it, and basically set these videos up that I'm producing, that I put out there, so that you can essentially follow along with the book. So if you have the book and you're reading the book, you can read that chapter, come to my videos, and actually get more information on that chapter, or another perspective on the information in that chapter. And while my videos should not be a replacement for reading the information and studying it and understanding it, my videos, if you watch them through, hopefully will provide you all the information you need to pass the exam. But again, I highly suggest that you use multiple sources for studying, not just the videos I produce. Anyone that says, hey, my video is going to be the end-all be-all to passing the certification exam, they're lying. People learn in different ways. People learn by putting their hands on stuff, or audibly, like listening to someone talk about it, or actually reading it and regurgitating it. I've seen people on YouTube videos talk about the A+ exam and say, oh, you don't even need to crack open a book. That, for some people that may be true, but for most, and since you're just entering the IT industry, or you may be a veteran in it, if you're a veteran, you know that not reading a book or not understanding the information is the wrong way about doing it. Yeah, you can pass the certification, but if you don't truly understand the information, you're going to be doing nobody any good. You're not going to be doing your customer any good. You're not going to be doing yourself any good, especially in your career. So it's very important that you crack open a book, you understand the information, and if you don't understand the information, that's what my videos are here for, is to help you better understand the information that you're hopefully learning. So enough of that. What I was going to do is I was going to talk about the OSI model. So if you're reading this book, the second chapter is about network protocols and standards, and it tells you why network protocols are important. Network protocols are definitely critical, as it says, to not only troubleshooting network communication problems, but it's also protocols and standards are important in the IT industry, because with protocols and standards, we create a standard of doing things, okay? It should be that you as a network technician, or you as a systems administrator, should be able to go into any network that any technician has been in before you and pick up right where they left off. Because if they're following the standards, if they're following the protocols of the industry, then everything should be set up the same. As far as like how the network's laid out, how it communicates, what firewalls are in place, how those firewalls are set up, things like that. We do have standards, and it's, for some reason, some people think that the standards aren't important, and they are, because I've walked into networks where, some technician decided that they were going to create their own color code for doing, shielded or unshielded twisted pair, and which is, when I say unshielded twisted pair, that's Cat 5 cable or Cat 6 cable. That's a network cable for your computer. So if you look at what looks like a phone plug, that's called a registered jack, or RJ45 jack. If you look on it, you're going to see, if you turn it over, you're going to see that each wire is a different color. And unfortunately, some technicians think, oh, well, if I make a match on both sides, I'm good. Well, the problem is if you have another technician come in and they follow the standards and they follow the protocols, when they see a network cable and they go, oh, this is wrong, and they cut off the end and they correct it, and they go, hey, this is what's going to correct your communication problem, the cable was wrong because it was out of the color code standard. Then they plug it in, it doesn't work, and they're have to troubleshoot and do all this stuff, and the high likeliness that they're bad mouthing you while they're trying to figure out why this stuff isn't working is very high. It's very evident that when another technician comes in and does work on someone else's work, and what they've done is wrong, I guess it could happen two ways. So it could happen like if you went in and you did work on a company's computers, and then another technician after you came in and basically talk shit about you the whole time they're there because everything you did was wrong. Or it could be that you worked for a company, everything you did was correct, you did everything along the standards and protocols, and then this other technician comes in after you. They don't know what the hell they're doing, so they go in and they do something screwed up, and guess who they're bad-mouthing? You. The good news on that is the IT community is a very small place. It's a lot smaller than most people realize, and the word gets around. So you will very quickly either tarnish your reputation in the IT community, or you will do very well for yourself, and people will, when they hear your name, they'll tell other people, yeah, he's good, whatever. They may try to still talk you down a little bit because they're trying to get your business. And unfortunately that happens a lot in the industry, but our industry is not the only industry that happens in. So you just gotta be good at what you do, because the customer will find out in the end. So if the customer is like, oh, well, when I hired Jacob or Joseph or whatever, and I had them come in, I hired them, they came out, they fixed the problem, and they were gone. There was no additional problems. And then they hire another technician because, well, customers are cheap. Okay, let's be honest. Most customers are always looking for the next best deal, right? So let's say they're cheap and they come in and they decide, well, you know what? I'm tired of paying for Jacob, or I'm tired of paying for whoever I have coming in, and gee whiz, I would just like to find someone cheaper. They'll find out very quickly that if they got the wrong person, that wrong person will cost them more money in the end than the person that was the good person, right? Because if you got someone that's coming in and they don't know what they're doing, they'll tend to screw stuff up, say they fixed it, and as soon as they leave, you find another problem, you're having to call them back out again, right? So customers aren't stupid, they figure it out. They are stupid in the fact sometimes that they'll leave a good technician because they figure that they can find a cheaper alternative. But every customer that I've had that's done that in the past has not left me very long. So usually they find out that the pasture is not greener on the other side, and they find out that I do know what I'm talking about, and I do charge less because, yeah, my hourly rate might be a little bit higher, but in the end, I'm charging them less because it takes me a quarter of the time to fix an issue that it takes another technician. Like I'll give you an example. Let's say I'm charging a customer $125 an hour to work on their network. I can go into their network and I can find the problem, fix the problem, and I'm probably there a total of an hour. If not, I'm there a little bit less, right? And I'll be fair with the customer and let them know and stuff. But they'll pay me, they'll probably bitch and say something like, oh, gee whiz, you were only here an hour and I'm paying you $125. That's kind of ridiculous. Well, the problem is they'll eventually sit there and go, well, I can go somewhere cheaper. So they go and they look in the phone book and they find some mom and pop shop, or they find some guy that knows how to use YouTube or knows how to use Facebook, or did his own work on his computer at one time and maybe helps out family, and all of a sudden he thinks he's a technician. I hate bad-mouthing people like that, but unfortunately there's a lot of people out there that are kind of like that, and what happens is they will basically hang their shingle and say, okay, I'm the technician now and I'm going to do this work for people, and the unfortunate part of it is they don't know what the hell they're doing. They learned through doing a search on Google, and they assume that that's the only way they're going to get answers. They don't understand that if they lose that internet connection, they're shit out of luck on getting answers. And so they'll come in and they'll charge a customer less than me because they want to prove that they can charge less than an actual knowledgeable technician. And they'll charge somewhere around, I've seen them charge anywhere from $45 to $75 an hour It ranges. And I try to tell customers, yeah, you can pay less by going to them, but I'll have your issue fixed in less than an hour. They'll have your issue fixed in, 3 hours, or if you're lucky, 2 or 3 days. And they'll charge you for every hour that they're working on it. So, and usually I'm right. So it goes back. I know I go on tangents, but it all goes back to the fact that if you're knowledgeable on the information, you're going to be like me. You're going to be able to charge a premium for what you do, but in the end, it's going to cost the customer less, because if they get the guy that doesn't know what they're doing, that's charging them, to work there for 3 hours at, $75 an hour, you do the math, by the time they get into the second hour, or halfway through the second hour, they're charging about what I charged. Once they get into the third hour, they're actually charging more than I charged. So, there's a joke out there on the internet, that there's a guy that, that goes to this shipyard after people have been trying to fix this ship forever, because there's a problem with the engine. And so he goes in, and they hire him out. He goes in, and he looks at the engine, and after examining the engine for a bit, he goes to his bag, pulls out a hammer, goes to a part on the engine, taps on it 3 times, and then tells them, okay, try to start it up. And they start it up, and the engine runs. And then shortly after that, they get a bill for, let's just say $10,000, because it's a big ship or whatever. And so the owner of the ship gets mad, calls the technician that did the fix, and says, hey, I want an itemized invoice for what you did. So he takes the invoice and he says, this much per hour, because that's the visit fee, and gee whiz, this is how much, because I know where to tap. It's all about knowledge and understanding the information. So standards are very important to understand, and that's what chapter 2 starts off with. It talks about NetBUI, and it talks about TCP/IP, which I will cover in videos. I'll go into detail on that and tell you how that works. Then after that talks a bit about, as I said, TCP/IP, which is the main protocol that the internet uses. There's 2 different versions of TCP/IP. There's the protocol itself is one protocol, but there's sub protocols, like you have IP version 4 and you have IP version 6. And IP version 6 is a much more complicated standard. It is what they've been saying for the last almost a little bit over 20 years now. They've been saying IP version 6 is going to replace IP version 4, and it's going to be so much easier, yada, yada, yada. You won't need this, you won't need that. The problem is we've been on IP version 4 since the creation of the internet, and I don't see it going anywhere anytime soon. And the reason why I don't see it going anywhere anytime soon, because it is the backbone of the internet, and everyone uses it. The good thing is IP version 6 is backwards compatible with version 4. So even if the internet itself stays version 4, you should be able to still use IP version 6 to do some of the other stuff. So it talks about routable, non-routable protocols. It goes into the OSI model. And the OSI model, if you were with me in my last stream, or you watched the recording of the last stream that I did last Wednesday, I talked about the difference between topologies. Okay, I talked about the difference between a physical topology and a logical topology, and that a physical topology was something that you could actually touch and feel, and plug something in, or look at the device, pick up a switch, look at the switch, things like that. They're physical items, and how those are connected dictates the physical topology. Whereas a logical topology is understanding how data flows through that physical topology. The logical topology is the understanding of how the data flows and how it communicates from one location to the other. The OSI model itself, if we look at it, it's basically it was created in the 1980s by the International Organization of Standardization, which their name is ISO. And then we have the OSI model. The OSI model is it stands for Open System Interconnect, and is made up of 7 layers. And when we say it's made up of 7 layers, we have to understand that the OSI model is not a physical thing that you can touch. It's one step above, I would say, it's one step above logical construct, meaning it's more of a theoretical. The best way to think of the OSI model is it's more of like a roadmap for you to understand where communication is happening in the communication stack, and helping you understand where to troubleshoot certain connections. So sometimes, not a lot, certainly in the certification path of Network Plus, or CompTIA Network Plus, or if you are going to CCNA, which is Cisco's Certified Network Administrator exam, or CCNE or anything like that, you're going to hear a lot about the OSI model, and they'll refer to it quite a bit. Unfortunately, in the industry, when you work with other technicians, it's usually pretty rarely that you'll hear them refer to the OSI model. Sometimes they will. But again, the OSI model is a good roadmap of understanding where to troubleshoot something and where things communicate. So the OSI model consists of 7 layers. So you have the application layer, the presentation layer, the session layer, the transport layer. You have the network layer. You have also the data link layer and the physical layer. And what's even more confusing is the data link layer actually has basically 2 layers to it. So it's broken up into 2 like sub layers. However, we say the OSI model has 7 layers, and again, those are application, presentation, session, transport, network, data link, and physical. And what I'm gonna try to do in the video that I'm gonna come up with here very shortly, I know I keep saying that, I swear to God, I am actually gonna produce some videos. I guess I'm trying to find my way right now. So what you have to understand is every communication works down the stack. So you'll have application, presentation, session, transport, network, data link, and physical. And then, so those 2 things will match on both sides. And if communication starts on the application side on one side, it's going to end up on the application side on the other side. And so the video that I'm going to come out with is going to talk about hardware at the physical layer. It's going to talk about what hardware works at different levels. For example, if we think of a network cable would be considered at layer 1 of the OSI model because it's a physical object. So the layer 1 of the OSI model is the physical layer. The physical layer is anything that you can actually physically touch. So that's like the network card of your computer. That's the switch on the network. That's a home router on your network. That's, again, anything that you can physically touch belongs to your physical layer. Your data link layer is more of like the physical addressing of your network card. It's the part that actually takes the signals and gets them ready to be transmitted over the physical aspect of that line. Then you get to the network layer, which is where we start talking about protocols. We start talking about things like IP version 4, IP version 6. If you were using IPS SPX, which is a obsolete protocol, that was a protocol that was designed by Novell, and Novell had their own protocol. It was something that only worked with Novell networks, and it was like IPX SPX and TCP/IP were like the Betamax and VHS of computers or of networks. To bring it even more current, it was like the HD DVD and the Blu-ray DVD disc of networks. So at the time, in all honesty, IPX SPX was a much stronger protocol that had a lot more capability in it. For example, IPX SPX, that protocol was it self-assigned addresses. It was self-configured. It had a lot of like future technology in it. However, what won the war for TCP/IP was that the internet decided to go with TCP/IP. So if you had a network that supported TCP/IP, it was much easier to connect to the internet than that of a network that supported only IPX SPX. That being said, again, it's kind of like Blu-ray and HD DVD. Blu-ray won because Sony pimped it out to all the studios, gave it to them for cheaper. Toshiba, who created HD DVD, is a better format, just like Betamax was. Betamax was better than that of VHS, but unfortunately, due to marketing and all that stuff, you know, Blu-ray won the war, even though their time at the top is going to be very limited because of things like the fact that we get to move forward with like digital streaming and stuff like that. That's kind of changed everything. So so at the network layer you have TCP/IP, and so you can name devices based on kind of where they're at in the OSI model. So if you have, let's say for example, you have a switch. A switch would be considered a layer 3 device, and the reason why it would be considered a layer 3 device is because a switch, depending on the switch it is, you have two different types of switches. You have switches that, the ARP, okay, the address record, I'm having a brain fart, but the ARP list that's on a layer 2 switch will record what they call the MAC address, which is the physical address of the network card. So it'll record the physical address of every network card that is attached to it. So when you connect a Cat5 cable from a layer 2 switch to that of the network card on the computer, it will then hold on a sec, give me 1 sec. Anyway, sorry. People forget I'm recording and I'm streaming live again. So anyway, so over the network, where was I? Brain fart. Network devices. So if you have a layer 2 switch, it's going to, in your ARP table, it's going to memorize the actual the actual physical address of your network card, and that's how it's going to communicate. That's how it's going to decide that when a communication comes into it for a device on your network, it's going to decide that based on the physical address. If we were to say that that switch was a layer 3 switch, that layer 3 switch would be able to determine where communication goes on the network based upon the IP address. Okay, so in its ARP table, it will actually list the IP address for the devices connected to it. So it'll list it in 2 levels. It'll list it as a physical address and as what they call logical address, the logical address being the IP address. And it's just 2 ways of basically skinning a cat. It's do I send it this path or do I send it this path, and how do I do that, right? If we were to say it's on the transport layer, then it starts getting into the upper protocols. And the protocols, there's many of them. So like transport protocols could be like FTP, or file transfer protocol, which is used port 21, and that's for transferring files over the net or over a network. It could be SMTP, which is simple transfer mail protocol, or small transport mail protocol. And that SMTP, that is port 25. And again, that's once you get into the transport layer, you're talking about different protocols. And as you get up into the OSI model, you go from lower layer protocols to upper layer protocols. When you get into session, you're talking more about security. You're talking more about making sure a session stays open. For example, this live stream would be considered a session on the network. You open this session to receive the digital information of the video, and while that session is open, you got a stream going to you, and you're allowing your computer to accept that information so you can view it on your screen. Typically, video is transferred in what's called a UTP packet, a UTP, I believe it. It's basically there's no checks and balances in the protocol that's sending the information. Some of this stuff I have to refresh myself on, and of course I'll do that before I actually produce the video, but it's all the same as far as like session. And then when you go to the presentation layer is starting to put things together for the application layer, which the application layer is the presentation layer is your Microsoft Windows kernel and OS exist in that session and presentation layer. And then right above that is the applications, where like if you're opening Microsoft Word and you're trying to save on OneDrive, that would be your application communicating with the presentation layer to send the information down. Now, the thing to understand about the OSI model is, although it is a theoretical stack, when we talk about communication and we talk about the OSI model, the application, presentation, session, transport, network, data link, and physical, okay, that's 7 through 1, the communication always has to go through it. So let's say your communication starts at the session level of the OSI model. If your communication starts at the session level of the OSI model, it's always going to use the layers below it. Okay, so if you start at session, it's going to use transport, network, data link, physical. And on the other computer that's receiving the communication, it's going to use physical, data link, network, transport until it gets to session. Okay, so I keep on looking up at my monitor. I gotta get used to looking at the camera so it looks like I'm actually talking to you. I'm still getting used to everything. I know that after doing some streams for a while, I should be pretty used to doing this stuff. But what you need to understand is if you take the OSI model and you put side by side, you take this OSI model and this OSI model, and you got application, presentation, session, transport, network, data link, physical, and I'll have a graphic for it in my actual video. But application communicates with application, presentation communicates with presentation, and vice versa. It's a back and forth communication. But you have to remember, in the OSI model, if something starts at the application layer, it may be on computer 1 may be communicating with computer 2 on the application layer, but every layer below that is being involved, okay? So every layer that's on this computer below application is being involved. Every layer that's on this computer below application is being involved. So you may have direct application communication, direct presentation communication, but down the stack, it's literally going application, presentation, session, transport, network. It's going through all those protocols to get to the end result, and vice versa when communication is going back and forth. So again, in the actual video, I will have a graphic that depicts this so you can better understand how this information communicates. But the book will go into much deeper detail about how each layer is involved, and what I'll try to do is in future videos, after I do the video about the OSI model and explain that, hopefully in more detailed and concise information than I'm doing now, when I go through that OSI model, after that point, I'll refer to the OSI model when I'm talking about something. Like I'll say, okay, remember UDP, I was calling it UTP before, UDP packet or protocols. We'll go into it later, I'm sorry. But in a network cable, I'll say, here's a network cable, this is Cat5. Remember, this is on the physical layer of the OSI model. Hey, this is a hub. This hub is considered a physical, and if it remembers anything, if it's a manageable hub, it is then considered also a layer 2 device. The hub usually is considered a repeater, so it exists on the physical layer or level 1 device. All right. They have a graphic in this chapter for the application, well, basically for the OSI model, and it's a pretty neat graphic. I'm not going to display it on the screen because I don't want to violate copyright, but this is general knowledge. But they say, the way they describe each one, they say the physical layer, and this is again coming from the CompTIA Network Plus Certification Study Guide, 7th edition, and all that information about this book is in the description of this stream/video. When I post the video, you will see the information for this book in that description. So these explanations are not from me. They are actually from that book. So I'll regurgitate that now. And they do have a nice little graphic that kind of explains it. So the physical layer, they say, places the signal on the wire. The data link layer is physical addressing, such as the MAC address. It also converts frames into signals. When we say frames, as we go up the stack, we deconstruct a frame. As we go down a stack, we build a frame. And you don't understand what framing is right now because we haven't explained it yet. But when you actually build a packet that communicates over or goes over a communication path, it is built as a frame. The computer needs to know where to begin and where to end on a communication, and we do that through framing. So it converts, as we said, data link converts frames into signals. On the network layer, we talk about logical addressing, which I was talking about earlier, which is TCP/IP. That would be like IP version 4 addressing or IP version 6 addressing. If IPX, SPX still existed, this would also be on that network layer because that's considered a logical address. We also talk about routing and the delivery of packets, how a packet is basically designed to go across the network. So when that packet goes across the network, does it get checked? Is there a check and balance? Like, does the receiving party ask to make sure that that packet is complete? Or is it like a UDP packet, where a UDP packet is just, the packet's sent across the network, and when it gets to its destination, that's the end result. There is no like return to make sure that that packet is complete. So that's one. The transport layer breaks data into segments, ensures the delivery. Session establishes and manages the session. Basically, it starts up the session with the other, like computer A is here, computer B is here, and the session layer starts the communication and makes sure that when it starts a session with computer B, that computer A and B have a direct line and are communicating the whole time and keeps the session open. Sessions typically are used for like a VPN connection would be considered a session, right? Because you're creating a virtual private network. You're creating a basically a path from one computer to the next, and that path is encrypted. And so that as long as that path is open and that encrypted path is open, that's called a session. And there's things in the session layer, okay, otherwise known as layer 5 of the OSI model, and there's checks and balances put in there to make sure that the communication is not only secure, but each party is still communicating on either side. Or if, like, let's say your computer A and computer B are communicating, and all of a sudden computer B drops out, computer A needs to know when to kill the session. Okay, so, and that's in the session layer. A presentation layer formats the data, enacts compression and encryption. So a lot of your security is actually enabled on the packet at this layer. It also, if let's say you're using compression or you're using encryption, both parties in the communication need to know what type of compression you're using so that they can decompress it. If computer A compresses a file and doesn't let computer B know what kind of compression it is, and if computer B doesn't support that protocol using compression, then it has no way of extracting the data. So obviously at that layer, since it's a presentation layer, both operating systems have to support that protocol, right? Then we go to the final layer, which is the application layer. The application layer initiates the request. For example, HTTP, that protocol actually exists at the application layer. So when you open up your internet browser and you go HTTP and you put in the address like www.msn.com, you're sending a request. Well, your browser doesn't know how your computer communicates through the network. So what your browser will do is it will actually communicate with the OS or the operating system of your computer and say, hey, I'm trying to do this, pass it down to the network stack, please, and complete that communication for me. And that's what your computer or the presentation layer will start to do, is it will start to build that frame or that packet, and then it'll send it to the destination. But on the application layer, the application that is asking for the information is genuinely stupid. It doesn't know how the communication happens. It just knows that it needs to communicate. So, that's again why protocols are important and stuff like that. So that's what the book describes. Hopefully I do a better job of explaining it in an upcoming video. But then the book does go through like a paragraph each on what the application layer does, what the presentation layer does, what the session layer does, transport, network, and so on and so forth. And it does break down. Remember earlier in the video I talked about the fact that the data link layer is basically two different layers. It does break that down a little bit for you, and I'll try to do that as well in my video. So it will tell you that, hey, in the data link layer there's the logical link controller, or the LLC, and then there's the MAC, or the MAC address, which is the media access control layer. Okay, and those are in the data link layer. Then the physical layer explains some of that, and then starts to talk about data encapsulation and talking about how we build a packet or a frame. And I'll, again, do my best to explain that to you as well. So, again, I highly suggest that if you haven't already, that you definitely check out this book. It is a very good book, and that's why I talk about it so much. Is I'm an advocate not of only watching videos and learning from other people, but I'm very much an advocate of getting the right material so that you understand the concepts of things and how to move forward with them. So this stream not only started late, but the whole time I've been streaming, I've had one view or one person watching, and I'm pretty sure that's probably me watching myself on my own stream. If there's anyone actually physically watching that would like to ask a question, please go ahead and add something to the comments or into the chat area. I do not have slow chat turned on, so you're able to ask as many questions as you want. I'll give a second for that to happen. If someone is actually watching and actually wants to ask a question. But I think I've done enough talking for this live stream until I think I've done enough talking on this live stream until we actually get some viewers. Hopefully Wednesday goes a little bit better, and hopefully Wednesday I'm on time. I don't like being not on time, but since I just got back from a trip with the family and I got help clean some stuff up, and the wife and I have to go to the store and get all that good stuff, I'm gonna cut this one short. It started late and it's gonna be cut short. Wednesday will start at 6 and it will go for at least 2 hours. Hopefully I have some more crap put together by then. But if you're watching this video after, thank you for sticking around this long. And if you have questions, feel free to add your questions to the comment section of this video. I always check them and I am more than happy to answer questions. So please don't hesitate to actually post questions. And if you would like to ask your questions live and get them answered live, please feel free to do that as well. So yeah, thank you for joining me today. Thank you for your understanding that I'm late to this one and that this one's being cut short. But I'll continue to do these. I may be slow on producing my videos because I'm still trying to get in my swing and stop being so critical of myself. But these live streams will continue to happen, and I will continue to try to give the best information I can and explain things so that people understand them. Other than that, I'm gonna go ahead and kill this stream. I wish everyone a happy evening. I wish everyone the best, and I look forward to seeing you again on Wednesday. Again, I'll start my stream on Wednesday at 6 p.m. Pacific time and 9 o'clock Eastern Standard Time. Thank you very much, and you have a wonderful evening.